This video is recorded based on the videos that the department sent to us, and the videos were classified to two sections. Section A was the compulsory section, and that's the computer section. And section B, we had a video based on your specialization, and to my case, my specialization is electrical. So based on the computer section, that was part A, we have a video of SCADA systems, and the SCADA in full means supervisory control and data acquisition. And the second video was based on industrial Internet of Things. So when we go to part B, the electrical part, we had video 1, which was electricity generation. Video 2 was about coal-fired power station, and video 3 was about electrical motor manufacturing. So as we start, first, I would like to thank the university management and our department, Technology Education Department, led by our able HOD, Dr. Kiprotich, and our facilitator, Mr. Olo, for coming up with such a program. This program came up to combat the effect of COVID-19. We realized that COVID-19 came in the year 2020, and due to this, it came with some restriction, and some of the restriction was avoid overcrowding. So we could not be able to visit industries based on western part of Kenya, that was Western and Kisumu. This is the trip that we were supposed to go to western part, that is Western to Kisumu, visit major industries in that area. So as I start, I'll start with video part A, that was the compulsory section. The compulsory section, as I had said earlier, is about SCADA system. And what is SCADA system? SCADA system is in full means supervisory control and data acquisition. So these are softwares. These are basically softwares used for monitoring, controlling, and analyzing industrial processes. So these are software. That means we have to feed this software with data. So when you have SCADA system in an industry, that means we have to feed the softwares with data. So the first process, we realize, that is data collection, and this data is collected based on what the industry offers. So we realize that the SCADA system has 4 functions. So the first function is data acquisition. The second function is data communication. The third function is data presentation, and the fourth function is controlling of sensors. So these sensors may be analog or digital, depending on the industry. So we realize that this SCADA system is used on various functions. The functions may include transmitting of electricity, transporting of gas and oil, traffic lights, and monitoring water flow. When we say monitoring water flow in an industry, we monitor water flow and distribution of water in the farm and the entire farm. So when we do this, the SCADA system is trying to monitor the speed, vis-a-vis the frequency of the water. So these are some of the functions of the SCADA, and we realize that SCADA is coming up to take the major industries in the field. So the second part was the industrial Internet of Things. So this provides a basis where you develop knowledge. On the industry. So we have to collect data, and accumulate this data. The data, as I've said earlier, the data is based on the industry. And we realize that this industrial Internet of Things has edge computing, which is used to capture the right moment. And when I say the right moment, we have sensors in the industry. When the right moment is captured, the sensors will detect that moment. For example, when we have a fault in a power line. So we realize that edge computing will detect the right moment by capturing that fault and responding immediately. So this industrial Internet of Things has 4 main characteristics. The first characteristic is filtering. The second characteristic is data information. The third characteristic is timely reaction and system resilience. So this timely reaction is what I've just said, capturing the right moment. So when we capture the right moment in the industry, we're able to save the industry from losses, several losses, which may include loss of important things. In electrical, we can say loss of conductors, maybe the circuit breakers will blow off. So when we go to the third section, the third section, the third section was power generation. So power generation is the most important thing, the most important thing in a power grid system. So power generation means that we have to generate power which will be supplied to the consumer. So right from production to consumer stage is what we call it electricity generation. So when we generate electricity, that means we have to convert one form of energy to another. Converting one form of energy to another, that means you have generated power. So we realize that generation of power may come in various forms, and generation of power may come in various forms, and therefore it is hazardous to environment. We realize that when we generate electricity, we are likely to produce carbon dioxide. And this carbon dioxide, when released to the environment, it is very dangerous. We realize that it will lead to global warming. And when we generate electricity, it may come with greenhouse effect. This greenhouse effect may lead to depletion of ozone layer, and this will lead to global warming. So the first thing we are doing when we're generating power, we realize that we have turbines, and these turbines are supposed to be driven by something. We have to find a force that will drive these turbines so that it will generate electricity. These turbines will have a shaft, and the shaft will be connected to a generator. This shaft will make the generator to run. So when we are generating electricity, that means we have to do something to these turbines. So the best method, we use steam. When we pass steam to a turbine, the turbine will rotate, and when the turbine will rotate, it will pass motion through the shaft to the generator. We realize that we are converting thermal energy to rotation energy. Like I have said, electricity generation means we have to generate electricity by converting one form of energy to another. So in this case, I have converted thermal energy to rotation energy. So as we are doing this, we have individual phases that will make smooth supply of electricity. So in electrical, what we are trying to say, if you're trying to produce power in large amounts, what do? We produce power in three phases. So we have the red phase, the blue phase, and the yellow phase. When we produce power in three phases, that means we are producing power in huge amounts. So that basically is about electricity generation. And we have several methods of generating electricity, which are classified according to the mode of which we are generating. In our country here, Kenya, the main mode of generating electricity is hydropower electricity. Hydropower, from the word hydro, that means we are producing energy using water. What are we doing using that water? That means we have to have reservoirs that will accommodate huge amounts of water. This water will have kinetic energy. This kinetic energy will move the turbines. The turbines then will have a shaft that will connect to a generator, therefore producing electricity. So hydroelectric is a form of producing power. Another form is solar. Solar is another form of producing electricity. Though it's not that much advantageous, since we only have sunlight energy during the day, and during the night we don't have energy. So sunlight is harnessed by solar, which has photovoltaic cells. So when we have solar, we are trying to harness heat energy from the sun. When we harness heat energy from the sun using the solar, we are trying to get we are trying to change that heat energy to electrical energy. Like I've said, the heat energy, the solar energy is not that perfect because we are only using electricity for half a day only. That means solar energy is not that perfect. The perfect method of producing energy is hydroelectric power, and that's what our country is using. Another form may be nuclear power, which is a bit expensive, and according to our economy nature of Kenya, we are not able to afford nuclear power. So as we go ahead, we are trying to get the part of coal energy. That was another video that we're told to watch, and the video mainly studied coal power in the US, in a place called Alabama, and we realized that this coal power produces 20% of the total electric power in Alabama. That means we are feeding, that coal power is feeding around 2,000 households, and that's a huge number. That's maybe a whole city. And this coal power produces about 2,900 megawatts of electricity. So as we start with this coal power, we realize that the coal power farm uses 3,800 tons of coal daily. So we have to transport 3,800 tons of coal daily to this coal farm. So I realized this coal farm in Alabama has 4 generating stations. So these 4 generating stations, that means the 4 generating stations has 4 different generators. So we realized that the coal may be brought in huge amounts and it needs storage. So the coal farm in Alabama has 7 silos which are used to keep the coal. So what do we do? When the coal reaches the farm, what is the first process? We realize that, like I said, in electricity generation, we have to change one form of energy to another. So when the coal reaches the farm, it is taken to a burner. This burner, from the word burner, that means we are burning that coal. And when we burn that coal, we want to produce steam. So this coal is burned at around 2,200 degrees Celsius. That's a high temperature. And before this coal is burnt, we have to mix that coal with secondary air. This secondary air, maybe oxygen, will help the coal to burn. So when we produce this steam, what do we do? The steam is used to drive turbines, like I've said. So when we have steam, we are subjected to a turbine, and this turbine will rotate. This steam will force the turbines to rotate. So when these turbines are rotating, we are generating kinetic energy. And what will we use to harness this kinetic energy? We'll use a shaft. This shaft will be connected to a generator, and this generator will be able to produce electricity. We realize this generator has a rotor and a starter. So this rotor will be moving at a velocity, and this velocity is measured in revolutions per minute. So this rotor is moving at 3,600 revolutions per minute. 3,600 revolutions per minute is a huge velocity. That means it will be able to produce a huge amount of electricity. That's around approximately 2,400 volts, which is enough to feed a whole city in Alabama. So as much as this coal is used, we realize we are producing huge amounts of heat, and therefore we need cooling mechanisms. So the coal farm in Alabama is near a water source, a river. So this river produces water, and this water is used as a cooling mechanism. So one unique thing about the coal farm in Alabama, it uses a closed loop circulatory system. It is like a breathing system. So once water is taken in, that means it is used it is used and reused and reused over a long period of time. We realize this coal has major advantage and it is environmental friendly. It does not pollute the environment. Though one of its limitations is that the electricity produced is not enough to fire to generate huge amounts of electricity and feed a whole system, a whole grid. So finally, uh, the video that was the last video to watch was electric motor production, electric motor manufacturing. So the video tried to explain how an electric motor is produced. So we have two types of motor. We have a DC motor and an AC motor. So an AC motor, that means is an alternating current motor, and a DC motor means is a direct current motor. So producing an electric motor is done in several stages, each stage having a significant role to play. So the first stage, it starts with the raw steak. We manufacture the raw steak. So we manufacture a raw steak. This raw steak is manufactured to a finished state. So once we are done with that, we are trying to produce the CNCs with a specific dimensions. We realize that a motor has a shaft, and this shaft is used to generate electricity. So we have, depending on the size of a motor, the shaft will vary. So the third procedure, we have to manufacture the shaft, and this shaft, like I said, it will come in different sizes, different dimensions, depending on the size of the motor. So as we have manufactured the shaft, we place them at a safer place, at a good place for later use. So after producing the shaft, we do the manufacturing, the machine frame. The machine frame, according to the video, is not produced by that firm. So the machine frame is supplied by a different company. And when the machine frame comes into the farm, we have to do primary coating. And the primary coating is applied to the machine frame, since the machine frame is coming from a different company. So after having the primary coating to the frame, we realize that the frame is washed. The frame is put in a machine where it's washed, and the washing is done with a purpose. We want to remove the metal coatings. The metal coatings in the machine frame is removed by washing. So we realize that electric motor has two parts: the starter and the winder. The starter and the rotor, sorry. So the starter and the rotor. We have to differentiate the starter and the rotor. So what do? We stamp the starter and the rotor. So once we stamp the starter and the rotor, we have differentiated between the starter and the rotor. Remember, the starter has some windings and the rotor has some windings. So these windings is done automatically by a coiling machine. So once the coiling is done, remember, it rotates as the winding is done. So all these processes is done by a computerized control system, which will make sure that we have the exact designs the users want. So when we are doing this, because a user comes in, then wants the specific design. So we have to computerize. So this computerized system is used to inspect if we have the correct designs. So once we have the starter windings, we finish the rotor windings. So remember, everything is done computerized. So as we are doing the windings, it is rotating, and we have the windings. Once this is done, assembly is done, and assembly is done. Then the starter lamination is firstly done, and we are doing it with an automatic welding. So the welding is done automatically with specific parts. Once you mess with this, that means you have to repeat the whole process. So automatically, we want to do welding automatically. So after all assembly is done, we test the machine. We cannot take the machine, the motor to the users if we have not tested the machine. So the last process is to test. We are testing to ascertain if any damage was done during assembling of the machine parts. So after we have tested and it is perfectly done, we do the packaging and transport to the users. So basically that was the videos that we watched, the summaries of what I watched and learned. So as I conclude, I would like to thank the department, the Technology Education Department, for coming up with such a procedure, such a program that is very educative. We realize that we have been able to get the exact skills that one would get from visiting such an industry. So we have saving on two costs, we have saved on two variables here. We have saved on time and cost. So this year there was financial constraints, and we realized that going to Kisumu was a bit hard. So this program came up, and we are very grateful to the department for coming up with such a program. Thank you.